All right, let's jump right in. Today, we are going to unpack something that has a lot of parents scratching their heads: second grade math. We're going to figure out what our kids are learning and, maybe even more importantly, why on earth they're learning it this way. You know that feeling? You look over your kid's shoulder at their math homework and you just think, this makes no sense. This is not how I learned it. Well, if that's you, you're not alone. Not by a long shot. The strategies can look really weird, almost backward, but believe it or not, there's a really smart reason behind it all. Okay, so here's the big idea. The whole game has changed. It's a massive shift away from just memorizing steps to get the right answer. The new focus is on understanding the concepts so deeply that kids can solve problems they've never even seen before. The real goal? It's to build actual mathematical thinkers.
So, this new way of teaching math is all about developing certain habits, certain ways of thinking. We're trying to build the mindset of a real mathematician, not just someone who's good at following a recipe.
The fancy name for this is the Standards for Mathematical Practice. But don't let the jargon scare you. Just think of it as the soul of the curriculum. It's not a list of things to memorize. It's a set of 8 key behaviors that define what it actually means to do math, instead of just, spitting back steps you learned by rote. Let's make this real. Take a look at these 3 big ones right here. First, kids are taught to actually understand a problem before they even pick up a pencil. Then, and this is huge, they have to be able to explain how they got their answer. They have to build an argument. And finally, they learn to see how that math applies to the real world. It's about understanding, communicating, and applying. The skills you actually need in life.
Okay, so what does this look like in the wild on a real piece of homework? Let's take a super simple subtraction problem and see the difference in action.
And here it is. This is the big difference. Over on the left, that's what most of us learned. Stock 'em up, borrow from the tens place. One way and only one way to do it. But look at the right. This is where the magic is. It's all about flexibility. One kid might use a number line, hopping back 10, then hopping back 8. Another might say, hey, 18 is close to 20. I'll subtract 20 from 42, which is easy, and then just add the extra 2 back. Or a third might add 2 to both numbers to make the problem simpler, 44 minus 20. See, it's not about making it harder. It's about showing that there are many ways to think about a problem. That's how you build real number sense. So, if that's the why, what's the actual what? What are kids learning day to day? Well, let's look at the 4 main buckets of knowledge they're supposed to fill up in second grade. Everything is kind of organized into these 4 big categories. You've got operations and algebraic thinking, that's mostly word problems. Then there's measurement and data, and geometry. But see that second one, number and operations in base 10? They're all important for sure, but that one is the absolute king. Yep, understanding our base 10 system, our place value system, is the single most important thing. It is the bedrock. It's the foundation of the entire house. And everything else in math, from multiplication to algebra to calculus, is built right on top of it. This is why teachers spend so much time here. Let me show you what I mean. Let's just take a simple 3-digit number, 734. Now this is so important. Kids today are taught that 734 is not just a 7, then a 3, then a 4 lined up next to each other. No, it is a package deal. It's a combination of 7 hundreds plus 3 tens plus 4 ones. Once you really get that you can break numbers apart and put them back together, well, that's the key that unlocks all those flexible strategies we were just looking at. And this is why second grade is so incredibly critical. If a kid doesn't nail this deep understanding of place value now, things like multi-digit multiplication in a couple of years, or decimals after that, they become almost impossible to really grasp. It's not an exaggeration to say this is the load-bearing wall for their entire math education. Okay, so let's zoom out a bit, because you really can't talk about modern math without talking about the elephant in the room, Common Core, and all the drama that came with it. So here's the quick history. The standards came out in 2010, and boom, almost every state jumped on board. But then, pretty quickly, a political backlash started brewing. People got worried about a loss of local control, and a bunch of states started to repeal and replace the standards. But this is where the story gets really fascinating. Take a look at this chart of the country today. Yeah, you've got some states that still call it Common Core, and a few that never did. But look at that huge bar in the middle. Those are all the states that rebranded their standards, but kept them almost identical to the original ideas. So what really happened here? Well, in a lot of states, it was basically a political performance. They would make a big show of repealing the Common Core name to prove they had local control. But the new standards they wrote were, for all intents and purposes, the same thing. They changed the label, but they kept the recipe. One source really nails it. It says there's, quote, a deep underlying consensus on the substance of a rigorous math education. What that means is, behind all the political noise, most math education experts actually agree on what kids need to learn. This focus on understanding, on thinking deeply. And there was another huge factor at play: money, the market. Textbook companies and software developers had already poured millions into creating materials for the new standards. So even when a state repealed Common Core, it was just way easier and cheaper for schools to use the same books. So in practice, we ended up with a kind of national curriculum anyway, even if we don't call it that. So let's bring this all home. How does it all fit together? What's the point of all this? The weird strategies, the focus on place value, the complicated politics. Why does it actually matter? The whole goal is to build a student who is truly proficient in math. That means weaving together the why, the thinking, with the what, the content. It's about knowing why something works just as much as knowing how to do the steps. And then the final piece of the puzzle is application, knowing when to use the right tool to solve the right problem. And this is the whole point. This is the end game. The entire system is built not just to make kids who are fast at arithmetic, but to grow a new generation of real mathematical thinkers. People who can reason their way through a challenge, who don't give up when things get tough, and who can use what they know to solve the messy, complex problems of the real world. So the next time you see one of those confusing math problems, maybe ask yourself this question. Are we just teaching them how to add and subtract? Or are we doing something way, way bigger? Are we building the creative, flexible, and resilient problem solvers that our future is going to need? Something to think about. Thanks for tuning in.